Hello everyone. Now I'm going to give you one concept on charged soap bubble. So here I have taken one charged soap bubble of charge Q. Q I'm charge I'm going to take here Q. Okay, and the radius of this one is R. Radius of this one is R, and surface tension of the soap bubble is T. I'm going to take, and now excess pressure inside the soap bubble thing already we know that is delta P. I hope you know this. Delta P is equals to 4T by R, where T is the surface tension, R is the radius of the soap bubble. Okay, now so delta P means inside the pressure, or otherwise inside the pressure or initial pressure we can take minus atmospheric pressure. So this is our outside pressure, which is equals to 4T by R, which is equals to 4T by R actually, right? So this is what excess pressure inside the soap bubble before giving the charge, right? Before giving the charge. Now what I am going to do, so here uh, so here, if you give a charge, and due to that charge, radius of the soap bubble is going to be increased, right? So radius of the soap bubble is going to be increased. That increase in radius we have to find, isn't it? Increase in radius we have to find. Initially, radius already we have given, that is R, and now inside the soap bubble is, let me consider like this. This is inside the pressure. Okay, inside the pressure in all directions, so there will be a pressure none. So in all direction we have a pressure like this. Okay, so this is inside the pressure, and the pressure exerted by the atmospheric pressure on the soap bubble, that is outside pressure. Let me consider this is PO or P atmospheric pressure. And when you add a charge Q to this soap bubble, now there will be electric pressure also. There will be electric pressure also. That electric pressure already we know that is sigma square by 2 epsilon naught. Sigma square by 2 epsilon naught. And here we have given that charge, right? So due to that charge, and electric pressure is going to be changed. That change in electric pressure we can write like this, which is sigma square by 2 epsilon naught, which is equals to, so here 1 by 2 epsilon naught we can write, and sigma we can write it as a q by 4 pi r square, right? Here I have taken capital, no problem. uh, q by 4 pi r square. Now, and as a result we are going to get like q square by 32 pi epsilon naught r to the power of 4. Okay, now, for example, if this is in equilibrium condition, right? Equilibrium condition, and this is what outward, this is what pressure, right? Along this direction we have a pressure, and along that direction also we have electric pressure also, right? Whatever the direction we have, and in same direction we have electric pressure also, right? In all direction, here electric pressure, and here everywhere we have electric pressure along the direction of the pi. So that we can write it as, for equilibrium condition, we can write it as initial or inside the pressure plus sigma square by 2 epsilon naught, which is electric pressure, minus atmospheric pressure, which is equals to 4T by R. Already we know that. Now, inside pressure minus atmospheric pressure, which is equals to 4T by R. And if you send this sigma square by 2 epsilon naught to this side, that is minus, we will get sigma square by 2 epsilon naught, and that sigma square by 2 epsilon naught value already we have derived. So that value is actually 4T by R as it is, minus q square by, here we have that value. Okay, here q square by 32, q square by 32, here pi square, right? Actually 32 pi square epsilon naught r to the power of 4. This is inside pressure minus atmospheric pressure. Okay, this is what we got, excess pressure inside the soap bubble due to electric pressure also. Okay, due to charge. Now next thing. Now here dpu we got, actually there's decrease in pressure due to change on the bubble actually, right, charge on the bubble. Now this is dpe already, if you dig and it is going to be decreased. Decreasing pressure means we can write minus q square by 32 pi square epsilon naught r to the power of 4 actually. And one more thing, if you take that if you take this one again, soap bubble, right, inside we have a constant temperature, inside we have constant temperature, isn't it? Constant temperature we have. At constant pressure, here we are talking about pressure and the radius, isn't it? So we are talking about radius means indirectly we are talking about volume also, right? At constant temperature, inside the soap bubble we have a constant temperature. Then according to the Boyle's law, we can write pv is equals to constant, right? So p into, this is v means volume of the sphere, 4 by 3 pi r cube, which is equals to constant. And here 4 by 3 pi is also a constant actually. 4 by 3 pi is also a constant, so that p r to r cube, which is equals to constant. So actually here I need to find the dr, that's why I'm going to differentiate. Here p is a variable and r is also variable. So by using uv formula I'm going to differentiate it, and I'm going to differentiate with respect to r. Now if you differentiate p with respect to r, dp by dr we can write, and r cube is a constant, plus if you differentiate r cube we will get 3r square, and the p is a constant, isn't it, which is equals to 0. Constant differentiation is 0. Now from this, dp by dr into r cube plus is equals to minus 3r square p, minus 3r square by 3r square p. Now this r square and r square gets cancelled. R square gets cancelled. And now here dp by p we can write, and minus here I am writing, and this is minus 3 dr by r. Sorry, here we don't have any minus. Okay. From this, dr is equals to we can write minus r by 3 dp by p, dp by p. So here this is minus dp by p means that is minus dp by p means that is decrease in pressure, right? So that is decrease in pressure. And now then, so pressure is decreasing inside the soap bubble means radius is going to be increase. Radius is going to be increase. Now the dr is equals to r by 3, and minus dpe means already electric pressure q square by 32 pi square epsilon naught r to the power of 4. And here in this we have by p also, that p I am writing as 1 by p. Okay. And if you solve this, I got like q square by 96 pi square epsilon naught r cube into p. So here whatever the p you are seeing, that is the initial pressure. Okay, initial pressure are inside the pressure. That p is equals to actually pi minus p atmospheric pressure, which is equals to, we can write 4t by r actually, isn't it? 4t by r. Now from that, uh, actually pi is equals to p, which is equals to atmospheric pressure plus 4T by R. Okay, 4T by R. This P I am going to substitute. I am going to substitute in this one. Now delta R is equals to, right? So delta R is equals to, right, or dr is equals to q square by 96 pi square epsilon naught r cube. P means we can write atmospheric pressure plus 4T by R. And one more step I am going to write, dr is equals to finally q square by 96 pi square epsilon naught. If you write r cube, I can write atmospheric pressure into r plus 4T. Okay, 4T we can take. This will be the answer for this question. Okay. Okay, Nana.